fractions is you take one fraction that is too difficult to integrate and you break that up into 2 or 3 easier fractions to deal with. The only way it'll work is if the denominator can be factored. So that's where we begin. So we've got the denominator can be factored. It's the difference of squares. So it's going to be 1 minus x squared times 1 plus x squared. And that can be factored even more. It would be 1 minus x times 1 plus x times 1 plus x squared. Then that means that this can be broken up into 3 fractions. So it would have 1 with the denominator 1 minus x, 1 with the denominator 1 plus x, and then 1 with the denominator 1 plus x squared. We're going to be using u substitution in the future when we get to this point. So to integrate this, we would let u equal to 1 minus x. The derivative of that is a number. And when you do the u substitution, that number is supposed to be showing up over here. So that means that this is going to be a number. We'll call it a. Likewise, this is the number b. If you're using u substitution over here, then u equals 1 plus x squared, du would be a 2x. So that means we have to have something with x in it, namely cx plus d. So if the degree is 2 down here, the degree should be 1 up there. Alright, now to clear out these fractions, multiply both sides by the least common denominator 1 minus x times 1 plus x times 1 plus x squared. Don't need to multiply this side by it as well. So I'm just going to write it up here at the top. 1 plus x times 1 minus x times 1 plus x squared on the right hand side. So on the left hand side, everything gets cancelled except for this 1. On the other side, the 1 minus x would get cancelled, but we would still have a times 1 plus x and 1 plus x squared. And then the b would have the 1 plus x cancelled, but it would still have 1 minus x and 1 plus x squared. And then for the cx plus d, 1 plus x squared will cancel, but we'll still have this, which I'll just go ahead and multiply that out. So it's going to be the cx plus d gets multiplied with 1 minus x squared. The next thing to do is pick some numbers for x. For example, for that x equal 1, this term will cancel and this term will cancel. And thus we can solve for a. So if you let x equal 1, we would have 1 equals a times, this would be a 2 and a 2, so that's 4. And the other terms get cancelled. So we've got the a, it is a 1/4. Now pick another number. For example, if we use a -1, then this term will cancel, and this term will cancel, and then we can solve for b. So let x equal a -1. So this one's cancelled, this one's cancelled. We would then have b times, if x is a -1, this becomes a +2 and a +2. So the b is also 1/4. Alright, now pick something else. Well, I suppose that an easy number would be if x equals 0. So then this would be a 1 times a 1 times a quarter. This would be a 1 times a 1 times a quarter. This would be gone, and this would be just a 1. So we would have the d. So it looks like this would be a half, so if you subtract half from both sides, we've got the d is equal to 1/2. And now we need one other number so that we can find out what c is equal to. So let's just try x equals 2. So we'd have 1. So if x is a 2, we've got a 3. This would be a 4 plus 1 is 5. So we've got 3 times 5 times 1/4. Over here, if x is at 2, this is going to be 1 minus 2, so that's a -1. This would be a 4 plus 1, so 5, -5 times 1/4. And then plus, so c times 2 plus the d. And then if you substitute a 2 in here, it's going to be 1 minus 4, which is -3. So this is 15 quarters minus 5 quarters is 10 quarters. So if you subtract 10 quarters from both sides, that would be, well, 4 quarters positive and 10 quarters negative is -6 quarters. That can actually be reduced to -3/2. And then I would go ahead and multiply. No, we might as well just divide by -3. So we could divide both sides by -3, and that would leave a 1 in the numerator on the left-hand side. And then we would just have 2c plus a half. This is now equal to a positive half because we canceled the -3. And this is a half, so if you subtract, that would be 0. That means that c is equal to 0. Okay, so now we have all of the parts we need. Now we can go back to the integration. So this one right here is going to be broken into 3 smaller integrals using the appropriate a, b, c, and d. So the first one is 1/4 for the numerator, and I'm actually going to factor that quarter out. Okay, so there's the first one, but I've factored out the quarter. Going to do the same thing here. So the b was also a positive 1/4, so factor that out. And then the c is a 0, so that's gone. The d is a 1/2, so that can be factored out. When I said factor out the b is a 1/4, so that's supposed to be a 1/4. Okay, then the d is a 1/2, and what's left is 1 over 1 plus x squared. All right, and after all of that algebra, we're ready to do the calculus. So over here it's going to be 1/4. If you use u substitution, we would have negative du over u, or you can just look at that and say, oh, that's natural log of 1 minus x, but the derivative of the inside is a -1, so we need to divide by a -1. The next one would be 1/4, and then that's natural log of 1 plus x. And then for this last one, you should just recognize that that is tangent inverse of x. So the last one is 1/2 tangent inverse of x, and then don't forget the constant of integration at the end.